Alright, rock stars, let's get rocking here. Big reminder, tomorrow, mid-unit test. So hopefully you're looking at this in preparation for your mid-unit test or did the self-test online as kind of assigned. So what we're looking for is just a little help on the homework, so let's get to it. So staying sharp, 14.16 questions. Let's get this wrapped up. So solve the following equation for J. Well, this is what we've been talking about the last couple of days. Let's go ahead and write it over here. We have J minus 4 is equal to negative 12. Okay, so what we're trying to do is solve for J. You guys know what to do. That means you get J by itself. So let's split this equation, which needs to be a common kind of organizational tool. We're trying to get J by itself. So what's around J that you need to get rid of so J is by itself? Well, I'm looking at this side of the equation. I see this big negative 4 here. Well, how do you get rid of a minus anything? Dot dot dot. You add it. So addition property of equality states if I add to one side of an equation with the express purpose of canceling, we're certainly going to have to add to this side as well. The 4's cancel, leaving me just with a J. On this side I have negative 12 plus 4. So think about this, negative 12 plus 4. Like if you owe me 12 bucks, you pay me 4 back, you still owe me some money. In fact, you're going to owe me 8 bucks. So negative 12 plus 4 is going to be a negative 8. And that's going to be the answer to the first one. Pretty straightforward, just solving equations. Bam, look at number 2. So you have this equation, 18x plus 12y equals 72. If x equals 0, find the value of y that satisfies the equation. Now this is oddly worded. What this is saying, if you have 18x plus 12y equals 72, what happens if x goes to 0? Well, this just becomes a substitution problem. Let's take this 0, let's stick it in for the x. So we have 18, instead of x we'll take a 0, plus 12y equals 72. In fact, again, just kind of reiterate, all I did is take this 0, because I know it's equal to the x, and replace it with that 0, just straight substitution. Now here's a cool thing. It is multiplied by 0, so these cancel. Boom, those are gone. I'm just left with 12y is equal to 72. So this breaks down to, well, how do I undo this times 12? By now, hopefully you guys are catching on that all we have to do is the opposite, which means I have to divide by 12. And of course, on this side, divide by 12 as well. Okay. If I divide by 12 on both sides, those 12s cancel. Leave me with just a y. I'm going to have to put it over here, guys. I apologize. So that y is right here. 72 divided by 2 is 6. So if x is 0, the y value that is there is 6. Same equation. Let's deal with 18x plus 12y equals 72. Now we're saying, well, what happens if y equals 0? Straight substitution, guys. So 18x plus 12, instead of that y, we'll put a 0, is equal to 72. Now we got to solve for the x. Again, just to reiterate, what happened is now I know y is equal to 0. Instead of this y, bam, putting in a 0. Now simplify, now let's solve. This 12 times 0, that's essentially gone. I have 18x is equal to 72. Well, how to get rid of that times 18? We're going to divide it. So divide both sides by 18. 18 here, 18 here. Those at 18s cancel. I'm left with x is equal to the result of 72 divided by which if I bring out the old calculator here, we have 72 divided by 18 gives us x equals 4. Okay? So again, we're just doing substitution. If we have this equation that we're told at the very beginning, well, what happens when I replace one of the variables with a number? I should be able to solve for the other one. Now you have to have good solving skills, but you can totally do that. Moving on to number 3. You have two numbers that have a sum of 19 and a difference of 5. Find those two numbers. Use whatever method you like. Now, guys, this is an awesome question. Awesome, awesome, awesome. What we have to kind of do is both set up some equations and then solve them. And we could use shapes, we could use variables, you can use whatever you want. But here's kind of the deal. If I have these two numbers, I'm going to say triangle, I don't know the number, and then I have, let's say, a circle. I add them together, the sum has to be 19. If I take those two other things, so I take this triangle and I subtract the circle, I know it's going to be 5. Now, finding these two numbers you can do a lot of different ways, but the method you're probably going to use more than likely is going to be something like guessing and checking. So I'm going to start up here. What two numbers can actually add to make 19? Well, you got a lot of choices. I mean, you got blank plus blank equals 19. And this is probably just going to be a straight up guess and check kind of process. Now, guessing and checking doesn't have to just be like picking numbers, trying them. We can actually do this very systematically. And this is something we've explored before. What I would do is actually set up a little table here. So we can do this in such a way that we're organized and making good choices. Let me explain what I mean. So let's have the triangle choices here, the circle choices here. In this column, we'll record what happens when I add them. And over here, we'll record what happens when I subtract them. And I don't really know what the numbers are going to have to be, so I'm just going to start picking them. So what if triangle is 10? Well, I know that they need to add to 19, subtract to 5. So my only choice really here is going to be a 9. So they add to 19, but here's the problem. They subtract to 1. That's no good. 10 and 9 add to 19, which is what I needed here. Subtract to 1, which is not what I needed here. So this is no good. This is a sad face one. So let's make some adjustments. What if I take this up to 11? Well, I still got to add to 19, which means I got to choose 8 for circle because 11 plus 8 is still 19. But 8, 9, 10, 11, that gives me a difference of 3. I need a difference of 5. That's no good, but you know what? Look at this. My differences are getting closer to 5. Let's kick this up to 12. If that's 12, I got to choose 7. And hopefully you guys are seeing some patterns emerging right here. 12 plus 7 is 19, but look at this. 12 minus 7 is 5. These are my numbers right here. So my triangle number is going to be 12. My circle number is going to be 7. So even though our method is guess and check, you can still do it very systematically. You can still make it very organized, and in the end, you can still get a good answer without just willy-nilly guessing. Like if you just started guessing without kind of recording what you're doing, my guess is an hour from now you're still going to be guessing. I didn't really have a sense of why I should choose 10 for my starting number. I just know I had to add 2 numbers to make 19, so I kind of wanted to start in the middle. And roughly in the middle of 19 is about 10. I could have started with 9, whatever. Once I had my first number chosen, my second number, since I know I had to add to 19, was kind of chosen for me. If I chose 10, I had to choose 9 to add to 19, and this is the one I was really checking. Okay, I had to follow 2 rules. They add to 19, they checked it to 5. Or sorry, subtract to 5. So I was going to make them so they always add to 19 and then keep choosing numbers so they actually subtracted from 5. In the end, this is my value. Tough problem, but certainly one you can do if you attack it using an organized list. Take a look at number 4. We got to solve the shape equation puzzle. Man, these are a blast in the past. What we probably want to do, though, before we do anything is kind of simplify it. Because I'm seeing like 1, 2, 3 triangles and a couple hearts. I'm thinking I can rewrite this as 3 triangles plus 2. Oh man, I can't draw a heart. Bam. 2 hearts is equal to 20. Down here, I'll do the same thing. Simplify it. I see 2 triangles and a heart. So 2 triangles plus a single heart is equal to 13. Okay, so now my question is, well, what do we do now? I simplified it because I know that's what I was kind of taught to do. But I don't know if that's really going to get me anywhere. Let's kind of back up. That's the kind of wonderful thing about mathematics. Sometimes your initial thought processes isn't one that actually works. Let's try this. Consider this. I have these things up here that equal 20. I have these things up here that equal 13. If I take this heart, and then these 2 triangles, and these 2 triangles, that means this much of it is 13. Okay? So really, this first equation is really going to be a triangle plus a heart plus 13 is equal to 20. So if we continue this line of thinking and we subtract 13 from both sides, that tells me that a triangle plus a heart is equal to 7. Now this is important because now we can start doing some backtracking. Let's go back to this guy right here. Using the same kind of logic we started with, the triangle plus a heart is 7. That means if I take these 2 guys away, that's really the same thing as 7. So I get 7 plus a triangle is 13. Well, if I subtract 7 here, subtract 7 here, because I know I can solve, the triangle in this case is equal to 6. If the triangle is equal to 6, that means the heart has got to equal 1. So in the end, we got heart equals 1, triangle equals 6. Not an easy problem. Got to use a lot of intuition, a lot of what we call substitution, a lot of solving. But in the end, these are two values that we're looking for. Okay, let's check this out. Sadie is buying a car. She wants either a coupe, which is a 2-door, and a sedan, which is a 4-door. Each type of car is available in red, white, and blue. List or draw a tree diagram of all Sadie's possible choices of cars. Now, we got to kind of remember what a tree diagram is all about. It's all about really making choices. So, check this out. Here's Sadie. I'm going to draw her. Bam, Sadie's wearing a dress. Alright, now she can make choices. Choice number 1 is really going to be a coupe or a sedan. So I'll take coupe to be a C and sedan as an S. Now when she makes, no matter what she chooses, a coupe or sedan, she has another question she has to address. Does she want a red car, a white car, or a blue car? So here's where we have another choice to break off. Are we going to choose this in red? Are we going to choose this in white? Or are we going to choose this in blue? Now, if you choose a sedan, we get the same set of choices. We got red, we got a white, or we got a blue. So Sadie has to make one choice. It either needs to be a coupe or a sedan. But when she makes that choice, she has to choose red, white, or blue. So in the end, this is the tree diagram she's looking for. Now, the interesting question to answer here is how many choices does she really have in terms of cars? Well, to do that, we're going to actually count the very last set of our tree. 1, 2, 3, 4, 5, 6. So she actually has a total of 6 choices. Now, it wasn't a question that was being asked, but we have to kind of think about why a question like this is important. And the end is important because it tells us how many choices she has at the end. She has one choice of either coupe or sedan. But when she makes that choice, she has 3 possibilities for each one, hence 6 total choices. Alright, last question. Manny flips a coin 3 times in a row. List or draw a tree diagram for all the possible sequences of flips he could get. For example, flipping a head and then 2 tails would be H, H, T. Okay, we're asked to make a choice here, whether we want to make a tree diagram or we want to make a list. And guys, let's go ahead and make both. Well, I'm going to make both. You guys can maybe just decide which one you like best. I'm going to start with a tree diagram because I'm a very visual person. I like this whole idea of a tree. So we have to kind of think of these flips in terms of like rounds. So I'll try to use 3 different colors. So let's think about this. For the first round, the first coin flip, which I'll write in black, there's only 2 choices that could come. He could either get a heads or he could get a tails. Unless you guys have some kind of coin that I don't know about. Now from here we got to acknowledge he has to flip a second coin. Okay. Now from here we have to attach it to our first set of flips. If he gets a head the first time, he really has 2 choices for the second flip. It can end up heads again, or it can end up tails. Now the same exists down here. Like if he were to flip a tail with his first coin, his second coin could still either be a heads or be a tail. So right now, hopefully you guys are seeing that if he only flipped 2 coins, he has 4 possibilities in the end. Let's move to number 3. Okay, for the third coin, again, following each of these possibilities, he can only flip either heads or tails, but that's going to be true no matter which path he has taken before. So in the end, what you're looking for is a couple things. You have to kind of follow the sequence going left to right. Each of these pathways actually does denote a separate listing of his possibilities. So in other words, he has 1, 2, 3, 4, 5, 6, 7, 8 different outcomes. He could flip heads, heads, tails. He could flip heads, heads. I'm sorry, head, 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 tails, head, tails, head. Tails, 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 head, tails, tails, excuse me. Tails, heads, heads, tails, heads, tails, tails, heads, heads, tails, tails, tails. So every kind of pathway that you take is going to be a separate choice. Allow me to demonstrate using highlight because that might be a little bit more clear. As I was saying that, I realized that it was getting kind of jumbled. So if you want to know how many different possible outcomes he has, we simply have to trace. And each of these pathways to the end represents one. So that would be one pathway, one possibility of what he flipped. Here's another possibility. That didn't really turn out like I thought. So that's the second one, tracing it this way. A third one is taking this first purple line up to the red line. And a fourth possibility is taking this purple line to this red line. And then down here we repeat. So here's one possibility, two possibilities, three possibilities, four possibilities. So if you didn't want to make the tree diagram to do that, you certainly could have made it by a list. In fact, I can argue the tree diagram helps us do that. So heads, heads, heads would be one list, one possibility. Heads, heads, tails would be the next. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. Now the list over here confirms what we found out in our tree diagram, that there are 1, 2, 3, 4, 5, 6, 7, 8 possibilities. 1, 2, 3, 4, 5, 6, 7, 8 possibilities if you flip a fair coin 3 times in a row. Alright guys, I hope this helps. Again, I'm sorry about the length of the video. I'm going to try to get these down compressed a little bit more. But in the end, if you want me to explain the problems, you want to see every one, it's going to take a little time. Notice it's still under 20 minutes, which is what we're claiming should take you to do your homework. Just saying. If you need extra help, have extra questions, please use Edmodo. Please post those questions. I know I'll be monitoring it tonight, so if you have anything you want to know before the test and while preparing for the test, you're free to answer those questions. Okay, so guys, I hope you guys this was useful for you. If you have any questions, post them. You guys have a great time studying. Thank you. Have a good night.